from the participants, there are people who are planning or who wants to upskill themselves in terms of networking by learning few technologies, but they are facing little difficulty where to start and how. So that is also one of the motivation which gave us to start. Yeah. So for this training, this time we have an expert instructor, that is Chirag Dhal. He is CCI Enterprise. He recently became CCSI also. So he's one of our core team from PyNet Labs. He's been there since starting, and he's going to be your instructor for this complete set, that is CCNA 200-301. Yeah. All the very best to you all for this exciting sessions. I'll request everyone to ask as many questions as you want from him in the Telegram group. Please be active for next 1 month in that group. All your technical discussions will be done there. Assignments will be also provided to you after every class, and class notes will be also there, which will be shared to you in the same Telegram group. Okay. Secondly, those, like, I received few questions or queries by the participants whether we are getting certificates or not. So to them, I just want to inform, try to give or try to make your first priority as to learn the concepts or to learn the technology. Second motive should be your to get a certificate or not. Okay, for that, try to attend more than 80% classes. We are there for you. After every class, we are getting some this class attendance. Our team, operation teams, is there who will be checking your attendance, and in the end, those who will attend more than 80% classes, we are going to provide them certificate, okay, which you can showcase on your CV, which you can showcase on your LinkedIn, anywhere. Okay. So yeah, this was regarding your certificates. And regarding the recording, it's not like we are going to provide you recordings instantly after the class, but yes, we are going to provide you the class recordings once you complete your training. Okay. So yeah, I think we are good to go, and all the very best. Over to you, Chirag sir. Yes, recording is already started. You can take the session now. Thank you. Yeah.
Thank you so much, Nitish. Hi, everyone. Welcome to this free CCNA 200-301 training. And I would again like to thank you, Mr. Nitish, for introducing me to the participants. So just a quick introduction about myself again. My name is Chirag. I'll be on this journey with you all to understand the basics of networking. I see that we have got a great audience here from different regions of the world. So greetings of the day to all of you. I'm hoping that I'm very clearly audible to all of you and my screen is visible to you guys. This training is going to focus on CCNA content. And like Mr. Nitish has mentioned, you guys can ask your questions, you can discuss your doubts in the Telegram group. So make sure you join that particular group, which we have for public available all the time. I mean, not just during the session, you can use that group later on also. You can discuss and ask your questions there. We are going to focus on the CCNA content, the very official content which Cisco provides. We'll try to understand and grasp all the topics that are there. And one by one, gradually, we'll try to build our knowledge on the fundamentals of networking. Some of you would be very new to networking. Some of you would be very probably having some experience with networking and are here for the revision purposes. So those who do have some knowledge, do have some experience, I would request you to be along with those who are starting it for the first time so that we all can understand and revise the concepts, as I'll be speaking about everything from the very scratch. So let's begin. Let's begin the journey. Let's try understanding what we are going to look at and how we are going to proceed towards understanding fundamentals of networking through this CCNA program. I'm really excited and I'm hoping that you all must be equally excited. So let's get started. Let's begin. All right. So before we directly jump onto CCNA content, I would quickly like to introduce you guys to how the certifications work and what you can probably plan further after getting your CCNA, right? As we all know, Cisco is a tech giant who leads the networking industry. Cisco offers three levels of certifications. We have got CCNA, CCNP, and CCIE. CCNA stands for Cisco Certified Network Associate. CCNP stands for Cisco Certified Network Professional. CCIE stands for Cisco Certified Inter-Network Expert. And as you might be able to already guess, CCNA is the first level, associate level, the basic level. Then we have CCNP, which is the professional level. Then we have CCIE, which is the expert level. Guys, CCNA can be your entry ticket to this domain, but that should not be your end goal, right? Because we do have multiple other certifications, multiple more complexities, more protocols to explore and learn in the journey. So CCNA can be your entry ticket that can help you definitely in landing onto a job or getting started with networking. But you definitely should look forward to understanding more about networks by pursuing your further certifications like CCNP and CCIE. CCNA program, which we are going to look at, is CCNA 200-301, which caters, or we can say, which teaches you on all the different verticals of networking. It gives you the introduction to routing. It gives you the introduction to switching, to security, to wireless, to automation, a bit of software-defined networking. So it basically is a combination of all the different verticals of networking so that you guys can understand what exactly there in the world of networking. Once you are done with your CCNA, the further you can go for is CCNP. Now to get CCNP, there are two exams. One is your core exam and the other is your concentrated exam. This is where you get to decide your specialization. For core and concentrated exam, there are different specializations that you can consider. You can go for routing switching. You can go for specifically wireless. You can go for specifically collaboration, specifically security, automation, and so on, right? So this is where you can decide basically what exactly is your area of interest and how you want to further proceed in your career with networking. Once you're done with that, once you have given the core exam and the concentrated exam, you will get your CCNP certification. Then the final boss level is CCIE. Now, CCIE can be achieved by a written exam and by a lab exam. So for the written exam, we basically consider the core exam that you have given in your CCNP. So this basically is the same thing. So when you are actually going for your core exam, you are not just clearing one exam for your CCNP, but you are also clearing it for CCIE. You are becoming eligible to go for the CCIE lab exam. This is how you can proceed ahead in your journey with networking. When you go for CCIE lab exam, there you are tested on a complex scenario, which you have to configure, which you have to manage and troubleshoot to make it a working scenario to fulfill the requirements that your organization wants. They test you there with various things, but that's not our topic for today. Our discussion right now is to get started with the journey, which is something we will do using CCNA. So let's quickly understand what exactly is the content of CCNA, which we are going to refer to. So CCNA's content is divided in 6 categories, in which the very first category is network fundamentals. Second category is network access. Then we have IP connectivity. We have network services. We have security fundamentals. And we have automation and programmability. The very first category is network fundamentals. Now, many of you would be learning about networking or will be understanding networking for the very first time, right? So you might not be aware what are the different network devices. You might not be aware what are the uh, different protocols or what is an IP address, what is an MAC address. So network fundamentals basically provides you all that information that you need to get started with the networking journey. So like all the basics, IP address, MAC address, OSI model, TCP IP. How does the different networking device operates? What are their roles? What are their functions? All the basics are something which we will learn in the network fundamentals section, and we will get prepared there to move further into the depth of networking. Then the next category is network access. So some of you might be aware of a device called switch. Switch is something that helps in connecting multiple devices together. We'll be definitely moving ahead. We'll be speaking about those things later on. But network access layer is all about switch configurations. So when we talk about the protocols which we perform or configure on switch, that's something which we learn here in the second category, network access. Third is IP connectivity. As the name defines, it is for connecting different networks together. IP. IP is IP address, Internet Protocol address, right? So when you want to connect different networks together, we talk about protocols, which we are going to learn at IP connectivity. Then we have network services. Sometimes you must be wondering that how, when you bring a new device to your home, you connect it to your Wi-Fi network and you are able to use internet, right? Like a few days back, I got this new smartwatch and I connected it to my Wi-Fi and I was able to browse internet through it. Or I can say it got connected to the internet. But how did that work? Who configured the IP on my watch? Who configured the protocols on my watch? So that's done using a protocol called DHCP by my Wi-Fi router itself, the home Wi-Fi router that configures the IP on my watch or any new device that I connect using DHCP. So how does that work? What are the different messages which are exchanged with the DHCP protocol? All of that we'll explore in network services and much more other protocols. Then security fundamentals. The name itself is enough to define what we are going to learn there. All the basics and fundamentals related to security, which can help you in understanding how you can secure your network, how you can make sure that your network is safe and secure. Lastly, automation and programmability. Very important and the need of the hour. Automation lets you write a script which can do your job, right? There are many day-to-day activities which we don't want to perform or which we want my PC to perform automatically. So that is something which we do using automation and programmability. will get an introduction to that as well. This is how the content is going to work. And this is also, I can say, a raw format of how we are going to proceed further in this particular CCNA journey. All right. Now, before I jump onto the topics again, a couple of things to always remember. There is link to the Telegram group in the chat box, which you can join. You are only allowed to discuss technical discussions where I'm in something meaningful, no unnecessary messages, otherwise you get banned. So the group link is there in the chat. You can join that group to ask your questions, to discuss your concerns and so on, right? Second thing, throughout the journey of CCNA, I'll be pasting some lab guides in the Telegram group itself. So those lab guides can be a great source of information and can be used for understanding and practicing protocols later on. Let's say when you want to revise or study about the topics which we have there in CCNA, right? Then finally, I'm hoping that everything is clear. I'm hoping my audio, my handwriting is clear to all of you. If we all are good, then yeah, you can give these reactions so that I can know we all are together here and we are good to proceed. Awesome. Great. Thank you. Thank you so much. All right. So now let's look at what we are going to speak about in network fundamentals. Akash, if you have got any questions or doubts, you can paste in the Telegram group. Those who have questions, you guys can put it in the Telegram group so that I can know your question and I can reply you accordingly. So yeah, meanwhile, let's understand what are some network fundamentals that we should be aware of. We'll try to take it as a story and a discussion only, and let's see where we get and let's see what we learn out of it, right? The very first question which I have for all of you is, what is a network? If I ask you guys, I have two PCs here. Is this a network? No, it is not. A network is created when we connect two devices or more than two devices together. Okay, the question is, why to connect? What is the benefit of creating a network? If I have, let's say, 5 devices in my lab and all the 5 devices are placed near to each other. So what exactly is going to be the benefit of connecting them together or building a network between them? Any guesses? Let me know in the Telegram group. Perfect. We got a reply. Communication, sharing resources and information. Very correct. This particular, we can say, term here, sharing resources, is what we require network for. Sharing resources is quite important. And anytime you want to share something, you need a network. You need communication between the devices, right? For example, if I want to share some files from my PC A to PC B, I need what? I need network. Correct? Similarly, if let's say I have a printer and that single printer is supposed to be used by all of the devices that I have in my small office, then what do I need? I need a connectivity here so that all of them can share this particular resource, which is a printer. But to implement something like this, what do I require? I require network, correct? So network is required, like you all have mentioned in the group, for sharing resources, sharing information, exchanging data, and sometimes sharing a single device over multiple users. That's where we actually require networks. A network can be of different types, right? Depending upon the geographical area that a network covers, there can be different types of networks. What do you know? What are the different types of networks that you are aware of? We have got LAN, MAN, WAN. Perfect. So the very first one that I want you guys to get introduced to is PAN, which is Personal Area Network. A small network that we create for a personal use or a personal activity. Sometimes we connect our smartwatch with the mobile device, right? Sometimes we share some files or data or images using AirDrop, right, between two Apple devices. All of these are examples of personal area network, which is a very small network that is created for a personal use. Can be wired, can be wireless. A Bluetooth connectivity is an example of personal area network, right? Second, that we have, which gets a little bigger from personal area network, is LAN. LAN stands for local area network. A local area network is basically a small network where I have connected a bunch of devices locally together at the same geographical location. For example, I have 10 PCs in my office. If I connect all of them, I can call that small network as local area network. I have, let's say, 5 devices at my home. If I'm connecting them together, that's a local area network. So a small setup having a bunch of devices connected together can be termed as local area network. Then after PAN and LAN, we have something called as campus area network. Campus area network is created for a specific campus. You can take an example of a college. You have a building which is for the science students, I mean the science stream. Then there is a building that has library. There is a building which is the reception of the college. So when you talk about these buildings individually, there will be a LAN here, LAN here, and LAN here. But when we connect all of them in this particular university, we can term it as campus area network. For this particular campus, whatever network I have established, that's going to be termed as my campus area network. Next, we have MAN, which is Metropolitan Area Network. Which is used to connect different cities together. If this is my setup or a branch in city number 1, and I have another branch in city number 2, and I connect them together, that's going to be termed as MAN. Then we have the final one, which is wide area network. Okay, quickly let me know in the group, what do you think? What is an example of wide area network? Internet. Perfect. Like right now, we have participants from various geographical locations. All of us are able to communicate with each other because of the wide area network, which is internet. Internet contains so many, we can say devices, millions of devices working together and millions of networks working together. So that's an example of wide area network. Then like Sujata mentioned in the group, a network between different states for a particular organization, for a bank, for any institution is also an example of wide area network. So when you connect, let's say your branches, which are in India and in, let's say, Singapore, when you connect these two together, you can term it as WAN. I hope so far whatever we have discussed is quite clear to all of us. If there is any questions or doubts, you guys can put it in the Telegram group. Awesome. Great. All right. So let's move ahead. Let's talk a bit more about some more fundamentals of networking. Another question for you guys is how a network is established. What all are the required resources inside a network? So basically, I want to know what are the components of networks. What is a network made up of? Don't worry, guys, notes will be provided to you. Okay, we are getting responses. There are switches, there are servers, there are routers. Perfect. What else? What about the end devices? Computers, laptops, these are also a part of network, right? Then what else? Anything else? To connect these devices together, what do we require? We require cables. Very good. Hari Krishnan. Ethernet cable. Perfect. Then do we require something on the software also? Protocols. Perfect, Michael. Protocols are also required, right? So when we talk about the components of networks, there are various things that work together to help us establish a given network. So we'll try to talk about some of them and we'll get an introduction to them alongside. The very first thing, just a minute. The very first component of network are network devices. Network devices can be categorized in two categories. First is endpoints. Endpoints are nothing but the end devices. The end devices are those devices which are used by the user. For example, server, a PC, a laptop, right? Or we can say printer, such things, right? Etc. Then, other than endpoints, a network device category contains something called as intermediary devices. So all these devices that you have mentioned, switches, routers, access points, firewalls, all these are called intermediary devices. So some of the intermediary devices are switches, Then we have routers. Then we have access points. Then we have something called as WLC, wireless LAN controller. We have firewalls. Then we have intrusion prevention systems or intrusion protection system. Let's quickly try to get an introduction to all these devices. Switches simply are the devices that allows us to connect multiple endpoints together. Endpoints are nothing but the end devices like PCs, servers, printers, or you can say or CCTV cameras, or anything that basically is used by the user. Switches are used to allow devices to communicate on the same network and is simply used for interconnecting multiple devices together so that these devices can forward traffic between each other. This, like I said, can only operate within the same network until and unless there is a special type of switch which we use. We'll talk about that later on. Next device that we have are routers. These devices connect different networks together. Okay. So for example, if you have your office network and you want that office network to be connected to the internet. So you need a router for that. Just like in your home, you need a Wi-Fi router to connect your smartwatch, smart mobile, your smart TV, or anything that requires internet. You need a router for that, right? Just like that, when you want to connect different networks or when you want your devices to be connected to the internet, you need a router for that. We have a question, what is the endpoint? So Vicky, the endpoints are the end devices, which basically includes PC, laptop, mobile phone, such devices. Then, like I said, there are some special type of switches which can operate some functions of routers, like connecting different networks together. So those switches are also something which we can use for connecting two networks together. We'll learn about those things later on. Then we have access points. These are used in wireless networks. I'll write it here. It's called access points. And these are used in, yeah, sorry. So yeah, these are used in wireless networks and are used for transmitting the frequencies so that the devices can be connected to the wireless network. WLC stands for wireless LAN controller. So wireless LAN controller is a central device which is used for managing different access points. So in my company, let's assume that there are 50 access points. So I can manage them just by connecting to a WLC. It's a central controller which manages all of the different access points which are there in my network, right? Then we have intrusion protection systems. These perform deep analysis on your data, your network traffic, and try to predetermine or pre-inform if there is some security issues. So you can get to know about them and can fix them so that you can protect yourself from possible network congestions, right? These are some of the intermediary devices which we find as the components of network. Other than endpoints and intermediary devices, there are media which also works pretty important, or we can say which also are quite important in the construction of a network. A media is basically the method through which you connect two devices together. Media is the physical element which connects two devices together, which can be fiber optic cables, which can be copper cables, which can be um, even sometimes air, because air is used for transmitting the frequencies from one point to the other. So that's your media. When we talk about cables, cables are inserted inside certain types of plugs, certain types of connectors, which are something we will explore in the session ahead. But media is again something very important in the establishment of uh, networks. Then another component in network is network services. Network services include the processes, the protocols, the applications that work together to help us establish a network. So services like emails or your web or your file transfers, all of these things are something that comes under the network services category. And this is how a network is constructed using all these different components, starting from the network devices, which includes endpoint, intermediary devices containing switches, router, access points, and so on, then media, then network services. There can definitely be more components, which we'll gradually explore and discuss in the coming sessions ahead. So far, if there is any questions, you guys can let me know. Amit, if you are not able to see my screen, you can try to drop the call and join again, and that will make it visible. Okay, you can give me a thumbs up if so far whatever we have discussed is pretty cool to all of us. Sham Sundar, let's try to focus on learnings first. Certificate will be definitely something we will address about. Mr. Nitish is going to guide you. You can keep your question there and someone will definitely answer about it. But yeah, I will definitely suggest you to be attentive and understand the concept right now. All right, I think we are good so far. The next thing that I want you guys to know, okay, we have a question. Whosoever is doing physical installation and testing activities at data center to provide internet and database management, is it helpful? Sorry, I didn't get your question, Kumar. Whoever is doing physical installation and testing activities. Are you asking if CCNA is helpful for them if someone is at data center performing installation and testing activities? If that's your question, then definitely CCNA will teach you a lot many new things that can help you in performing the analysis in a better possible manner. Secondly, it will be there to help you upgrade yourself. You will learn something new out of it, I'm pretty sure, and can be used for upgrading yourself. We have a question how to apply the attendance. You need not to worry about it. You just need to be present and Microsoft Teams automatically generates the attendance. So we'll take care of that from the backend. Don't worry. Firewalls. Okay, I missed on speaking about firewalls. Firewalls are the devices which work as the watchman of our society. Just like we have a security man who is taking care of who enters my society or who goes out of the society. Just like that, firewall is there defined with some security rules that can monitor my incoming and outgoing traffic and can make sure only the safe data or safe traffic enters my organization, not something which can harm my organization or my database. Yes, Kumar, it is going to help you definitely. Is it mostly? No, it's not like that, Kumar. Okay, a quick clarification here. Some of us might be assuming that is it just about physically working with the installation of network devices? Definitely no. There are different roles in network industry. Some includes you to be on field and do the installation stuff, but most of the other ones, the network engineer role is about configuring, managing, and troubleshooting networks, where you have to sit, you have to be on a computer, you have to access devices, take uh, the access of devices, monitor them, and find out if there is a problem, fix those problems. So that's actually the role of a network engineer. Okay, we will definitely address your career related questions as well. As of now, let's focus on the session only. So if there is any technical query, then let me know. Otherwise, I think we shall move ahead. All right. So firewalls, like I said, yeah, it is used for securing the incoming and outgoing traffic. Other than these things, when we connect two devices, I can definitely mention some of the mandatory things that I require here to build it as a network. What are these mandatory things? The very first thing is IP address. IP address, guys, is the name that we use for network devices. For example, if I want to call one of you, I might call you by your name, right? If I want to tell you something, I'll call you by your name and then I'll address your question or give you a reply. But when we talk about network devices, we do this communication with the help of IP addresses. If PC A wants to send something to PC B, it will send it on the IP address of PC B. IP address example is something like this: 200.10.1.1. This is how an IP looks like. We are later on in the session going to discuss much more about IP addresses, how IP addresses are defined in different classes, what are the different versions of IP addresses, what are the different types of IP addresses, and so on. Then second thing that I need is the MAC address, the physical address of the device. And the third thing I require is TCP IP. TCP IP is the networking model, which basically is a stack of all the network services that I might require. TCP IP stands for Transmission Control Protocol, and IP stands for Internet Protocol. So there are different layers that work together in TCP IP to make a network communicate or to let devices communicate with each other, which we are going to learn later on in the discussions. As of now, just understand that these are some mandatory things which we require to establish the network. Again, a very quick question. Why do we need the network, guys? Can you let me know again? What was the need of creating a network? Communication, right? So when we talk about communication, there can be different types of communication which might take place between devices. There are three types of communication. Very first is unicast, which is one-to-one communication. One-to-one communication means one PC sends some traffic to the other PC. So this type of communication is unicast communication. Second is multicast communication. Multicast is one to many, where if I have, let's say, multiple devices connected to me, I'll send some traffic to a group of devices. Like here, I'm sending traffic only to these two devices. So that's a multicast communication. I'm sending it to more than one, but I'm not sending it to all of them. So that's a group that I'm addressing. That's a multicast communication, one to many. Then we have the third type as broadcast, which is one to all. So from one PC, when I send something to all of the connected devices, we call it a broadcast message. Like right now, if I send some message in the group, let's assume that we have a complete community here of somewhere around 4,500 people on the Telegram group. And if I send a message, it will get delivered to all of them, right? That's broadcast. Out of that 4,500, some of us who wish to learn CCNA are here on Teams call. If I give a message here in the Teams chat, that's multicast. But if I directly message you on Telegram, one to one, that's going to be unicast. Then finally, IP version 6. So we have two versions of IP addresses, version 4 and IP version 6. IP version 6 introduces us to another type of communication, which is anycast. Anycast stands for one to nearest. In this type of situation, what happens? A PC can be connected to different servers. All the servers will have the same IP address configured on them. So whatever device would be nearest to me, I will reach out to that particular device for getting my requirement fulfilled. So when we go for one to nearest, we call it anycast communication. And this is supported with IP version 6. What is IP version 6? Something which we will discuss later on in the session in much more detail. But as of now, these are the four types of communications which operate between the devices when we send some traffic. Okay, we'll take a short 10 minutes breather here, a small break for everyone to freshen up, and then we will dive again into the discussions. Meanwhile, if you have got any questions, any doubts, the Telegram group is active. You can paste it there. I'll reply to those questions once we are back. So break for 10 minutes. Right now it is 3:53 as per Indian Standard Time. I'll be back by 4:03 and then we will continue. All right, everyone, let's continue. Let's continue the discussion ahead and understand more about the concepts. The next thing that I want you guys to understand are the different types of topologies that we use in the networking scenarios. So there are two types of topologies. There is physical topology and then there is logical topology. Let me introduce you, first of all, to physical topologies. Each network has both the physical topology and the logical topology. Physical topology of a network refers to the physical layout of devices and cables. For example, one PC is here, one PC is here, one PC is here, one PC is here, one PC is here. They all are connected with a switch like this. So when I define how my PCs are placed, how my devices are placed, how the cables are connected, that's physical topology. Then on the other hand, we have logical topology. Logical topology is the path which data travels from one point to another point in a network diagram. So basically, when this PC wants to communicate with this PC, it will go like this, right? Or let's say when this PC wants to communicate with this PC, it will go like this. So the logical path, the path that my packet would travel from one end to the other end, the definition of that particular detail is what logical topology is all about. Logical topology tells you how the bandwidth is being provided between the links, what type of interfaces are being used, what are the IP addresses configured on the devices. So the information that can help you in understanding a PC might take what exact path to a particular destination. That's what logical topology teaches us. The logical and physical topology can sometimes definitely be same for a given network and can also differ at times. There are different types of physical topologies which we can speak about. The very first type is the bus topology. Have you guys ever heard of bus topology? So a bus topology is when every node of your network, node means the devices, or every workstation of your network is connected to a common transmission cable, a single cable. And this is called the backbone or the bus of the topology. Each workstation is going to be directly connected to every other workstation with the help of this type of topology. For example, I have a workstation here and a workstation here, workstation here, workstation here. They all are connected to each other, let's say over a single cable or single transmission medium. In that case, I can term it as bus topology. So in this situation, all these PCs are directly connected to each other over this single medium of transmission. Then we have got something called as ring topology. And as the name defines, in this type of topology, the devices are connected with each other, creating a ring. So one device is going to be connected to the other device in the succession, and the last device is connected to the first one. So let's assume this is my first device, this is my second device, this is my third, this is my fourth, and this is the fifth and the last device. So like I said, every device will be connected to the next device like this. like this, like this, like this. And the last device which we have, the fifth device, will be connected to the first device, creating a ring. So this type of construction is known as ring topology. Then we have star topology, the most common topology type that we find in networking. In this, there is a central device which connects all the other network devices, like I created earlier. So if there is first PC, second PC, third, fourth, and fifth, they all will be connected through this switch. So this type of connectivity is called star topology. This topology includes star or sometimes extended star, where basically the connected device can also be a switch like this, and that might be connecting to again some more workstations like this. So this is a extended star topology. Okay. Wherever there is a central device connecting to multiple other devices and bringing all of them together in the same network, that is your star topology. Then we have mesh topology. I'll write it here only. Then we have the mesh topology. In mesh topology, a device is connected to all the other devices. For example, if I have, let's say, router number 1, router number 2, router number 3, and router number 4. So all these devices will be connected to each other. We can say R1 will be connected to R2, R1 to R2, R1 to R3, and then R1 to R4. Then R2 also will be connected to R4 and R3. Because with R1 it is already having a connection, right? This connection, so we don't need a duplicate connection. Similarly, when we speak about R3, R3 is now connected to R1, is connected to R2. So it will create a connection with R4. This type of connectivity is mesh topology, where all the devices are connected to all the other devices of the topology. These are called the physical topologies, which defines how my devices are connected in my network. Whereas when we speak about the logical topology gives us the understanding of how the path is taken by a certain device to reach a destination. For example, assume that my network diagram is like this. There is a switch connected to PCA, PCB, PCC. Switch is connected to a router. Router is connected to another router. Then probably this router is connected to two more switches. Switch 1 connecting to a server, and then switch 2 connecting to two more workstations. So when I say what path will be taken by PCA to reach this PCD, I can say that path will be first PCA to router to this switch to this PC. So this is the definition of logical topology, which explains how a packet will travel over different devices to move from a particular source to a destination. Does that make sense to everyone? If that's clear, give me a thumbs up. If that's not, you can put the question in the chat box. Awesome. Okay, Vicky, I can explain one more time. The physical topology is okay, we have to be very clear here that these physical or logical topologies are not something that we have to choose between. These are two types of understandings of our network diagram. When we talk about physical topology, it is telling us the physical layout, how the devices are placed. When we are talking about logical topology, we are understanding what path is taken by a particular packet to move from one source to the destination. If your question is which one is the best one out of these four, then usually nowadays we prefer star topology or mesh topology depending upon the requirement. Why so? Because these two types of topologies have high possibility of failure. If even one device goes down or this transmission cable, the backbone cable goes down, then the complete network goes down, right? In this case, if the network between these two goes down, then this PC can't reach the other devices also. So again, that's a problem, right? So that's why we mostly find the star topology and mesh topology in the networks nowadays. Then if I repeat about the difference, physical topology is the physical layout, like I said. Logical topology is the idea about path which my packet is going to take when the data will flow from one device to the other. I can send the notes, no worries. Let me know if there is any other questions. Awesome, cool, perfect. So Lokesh has a question here. Who decides the logical path? Who will find out or who will decide that if PCA wants to reach PCD, then what exact path will be taken? There can be another router here. And another possible path for this is that PCA might go like this and reach the destination, right? PCA to router, then here, then here, then here, and then to the PCD. So these things depends upon cost, metrics, and the protocols that we are using. So router, very correctly mentioned, Mohammed. Thanks for that. Router is the decision maker who will find out what is the appropriate path on the basis of metrics and cost values, and these are few things which we are going to explore in this journey. That's what CCNA is all about. So we'll learn how different protocols are enabled, how these are used, and how these are configured, or how they decide which path will be the best path. So all of that is something which is going to be discussed in the content. So yeah. Any other questions? What about hybrid topologies? Hybrid topology, guys, is a combination of two types of topologies. So if the topology is a star topology and also maintaining a mesh connectivity, so that's a hybrid topology. For example, if let's assume that these routers were connected through a switch, right? Like this. And then they are also connected with each other over dedicated connections. So it's helping us constructing a star topology and also catering the use of mesh topology. So these type of connectivities are hybrid topologies, which offers two topologies, or we can say two types of topologies in the same setup. That's your hybrid topology. Vicky, don't worry about practical lab and stuff. We will be looking at practicals. This is the very first session. Like I requested all of you, there are some sessions which are going to be from the very scratch. And because we have participants who might not be having a good knowledge on networking, so we'll speak from the very basics. We'll gradually, step by step, move towards the labs also. We'll practice all the configurations. We'll understand how packet flows between the devices. So all of that is a part of our training. As of now, this is the very first session, so we'll keep it simple and basic today. All right. Now it's time to look at the different types of cables. Now it's time to understand what are the different types of cable connections that we can use between the devices to connect one device with the other. And what are the different technologies that gets between the cable connections to help us understand what is the appropriate cable type that I can use between the devices, right? The very first type of cable is coaxial cable, right? The coaxial cables are used, I would say were used earlier back in days and was used for connecting the devices over a braided metal conductor. Okay. So it was quite a thick cable, very expensive, very difficult to install, and was usually used with cable connections, the TV cable connections or internet connections, right? Then later on, we got something better, copper cables, under which we found twisted pair cables, which have two categories, STP, UTP. STP stands for shielded twisted pair. UTP stands for unshielded twisted pair cable. What do you think would be the difference between STP or UTP? It is the difference of shield. As the name defines, the shielded twisted pair cable comes with a shield that protects the cable from possible physical damage or disturbance or noise. And then there is UTP, which is unshielded twisted pair cable, where there is no shield around the cable and is simply used in safe environments or home environments where there is less possibilities of physical damage. Then obviously because shielded twisted pair cable comes with a shield, it's going to be expensive, right? Whereas when we talk about UTP, comparatively UTP is cheaper or inexpensive, right? UTP is the common one, most common one, whereas STP is only used in certain environments where there is possibilities of crosstalk, where there is possibilities of physical damage or a harm to the cable, right? Like in a factory, you might go for STP, or in an outer environment, you might go for STP. But when you want to connect some devices in your home or in your office lab, then you might go for UTP, unshielded twisted pair cable. I'll show you some images of that as well. STP versus UTP. Here we can see that in the UTP cable, there is no aluminum shield or shield that protects my twisted pairs of the cables, right? But in STP cable, there is this shield here present to protect my twisted pairs of the cable, right? Then, if you pay a little attention here, these cables are twisted together and there are 8 endpoints which are twisted together, right? In both the scenarios, UTP or STP. So basically, there are 4 pairs in the twisted pair cable, which helps us in managing the voltage and exchanging data between the devices. Okay. These are inserted into a connector, or we can say these are clipped inside a connector, which is further inserted in the Ethernet port of our PC. How does that work? As we can see, there are 8 pins, and these are twisted together like this, right? These are further inserted into a connector called RJ45. This RJ45 is then connected to the Ethernet port of my PC, or I can say the network interface card of my PC. NIC or network interface card is basically responsible for receiving the data from these cables or transmitting data to these cables. And to connect my cable with the NIC network interface card, the connector that we use is RJ45. Let's have a look on these things as well, RJ45 and my network interface card. So here I'll make a search for RJ45. And I'm pretty sure you all must have seen a connector looking like this. Yeah. This is your RJ45 connector. So the 8 pins of my cable will be inserted inside this RJ45 connector. And then this RJ45 is inserted in network interface card. Let me show you an image of that as well. This is an example of network interface card, and you can see there's this Ethernet port inside which the RJ45 cable is connected. Nowadays, when we talk about the laptops or the workstations, they usually come with wireless NIC, which only has the ability of connecting with the wireless networks. So that's why you don't find usually an Ethernet port nowadays on the uh, laptops. But there can be definitely some extensions that can be used to add a Ethernet port from to your laptop. Then when we talk about copper cables, there are two cabling standards that get into picture, which helps us in identify what type of cable is it. If you see, there are some colors which are being used here. There is blue color, there is orange color, there is brown color, and then there is green color. Along with these solid colors, there is a cable which is a combination of that color and the white color. Like you can see here, this is the blue and white cable. Here is the blue, orange and white cable. Then we have brown and white and green and white. So these coloring schemes helps us in identifying two types of cables or two types of connections. What are these two types of connections? Let's try to understand. So there are two cabling standards, crossover and straight through. When we talk about straight through cable, it is when the colors are same on both the ends. I'll explain you what exactly that means. And is used for connecting different types of devices. You can say used for connecting different types of devices. Whereas when we talk about the crossover cable, A crossover cable is when the color codes are different at both the ends. In straight through, it is same. In crossover, it is different. So crossover cable is used when you are used for connecting same type of devices. Different type of devices means when you connect PC to a switch, you will require a straight through cable. When you are connecting a router to a switch, you will require a straight through cable. But same type of devices means when you are connecting a PC to another PC, that's where you require crossover cable. Similarly, when you are connecting a switch to another switch, you require a straight through cable. Sorry, a crossover cable. The question is why? When we talk about the Ethernet ports or the cables, they both have 8 pins. Assume that I have my PC here and I have a switch here. Okay. So on my PC, I'll have an Ethernet port. On my switch, I'll have an Ethernet port. On my PC, I have 8 pins. Pin number 1, 2, 3, 4, 5, 6, 7, 8. Similarly, I have 8 pins on the switch as well. 1, 2, 3, 4, 5, 6, 7, 8. Out of these 8 pins, only 4 pins are used for data transmission. What are those 4 pins? Pin number 1, pin number 2, 3, and 6. So I'll erase the other ones. We don't need 4 and 5. We don't need 7, 8. These are the only pins that we use for data transmission. When I speak about the PC's side, the pin number 1 is used for transmitting, then receiving. For transmitting data, the pin number 1 and pin number 2 is used at the PC's end. And for receiving data, the pin number 3 and pin number 6 is used. But on the switch side, the first pin is used for receiving, second pin is used for receiving, third is used for transmitting, sixth is used for transmitting. So guys, if I want a successful communication between these devices, can I say that I just need straight connectivity from 1 to 1, 2 to 2, 3 to 3, and 6 to 6, so that when this side transmit, other side can receive, and when this side transmits, other side can receive. Can I say that? Yes or no? Right? So this type of connectivity, when I have different devices, is what is straight through cable. So you can memorize it like this. You have a straight connection. That's your straight through cable. But if you have two PCs which are supposed to be connected together, so one PC would have pin number 1, 2, 3, and 6. The other PC would have the pin number 1, 2, 3, and 6. On one side, it is transmitting, receiving, receiving. On the other side also, it is transmitting, receiving, receiving. TX represents transmitting and RX represents receiving. So in this type of situation, if I want a successful communication between the devices, I'll have to make sure that my transmitting pin gets connected to the receiving pins and the receiving ones get connected to the transmitting pins. And this type of connectivity is known as crossover connection. So when you have same type of devices, you will go for crossover cable. When you have different types of devices, you will go for straight through cable. Exactly. Subhranshu has explained the same thing, which we have just discussed. So very well explained, Subhranshu. Good job. I'm hoping that we all are good so far. Now we are again to a question that how to identify. Console cable is a different thing that's used for connecting to the console or the CLI of the device. We'll reach there, guys. We'll understand everything. Don't worry about that. But yeah, as of now, we are again we are again ended up to a question that how do I figure out which is the crossover cable and which is the straight through cable. So like I told you, when it's going to be a straight through cable, the color code are going to be same on both the ends. And when it's a crossover cable, the color codes are going to be different on both the ends. Let's first of all understand what are the different color codes. So there are two color codes, 568A and 568B. As per 568A, the color number 1 should be white and green. The color number 2 should be, or the cable number 2 should be green. Cable number 3 should be white and orange. Just a minute, guys. Yeah. So I was saying the pin number 3 or the cable number 3 is white and orange. And cable number 4, as per 568A, is going to be blue. Cable number 5 will be white and blue. Cable number 6 will be orange. Cable number 7 will be white and brown. And the cable number 8 is going to be brown. That's how the cables are defined as per 568A wiring. Then what is 568B now? Let's understand. As per 568B, the first cable is going to be white and orange. Second cable is going to be orange. Third is going to be white and green. Fourth is going to be blue. Fifth is going to be white and blue. Sixth is going to be green. Seventh will be white and brown. And eighth will be brown. Okay. We'll forget about these two standards for some time. I said that if it is straight through cable, then the color codes on both the sides are going to be same. They're going to be same on both ends. That means if on one side it is 568A, then on the other side also it will be 568A. Similarly, if on one side it is 568B, other side also will be 568B. But if we talk about crossover, then it will be different on both the ends. Which means if it is 568A on the first end, then it should be 568B on the other And if it is 568B here, then 568A on the other side. The question is why? If I say I have a straight through cable, I'll have 568A on one side and 568A on the other also, correct? So I'll paste it here. This is 568A on one side. Then on the other side also, I'm assuming we have 568A. Guys, if you see this, it's simply a straight through connection, right? The white and green cable is moving from pin number one to the other side's pin number one. Similarly, the cable number two, which is green, is also taking the same position. Pin number three, which is white and orange, is also same, and pin number six, which is orange, is also same on both the sides. So that's what we learned with straight through cable. That first pin will simply connect to the other side's first pin. Are we clear why straight through cable requires the same coloring code on both the sides? Yeah, so this is my straight through cable. Then if I speak about crossover, we'll have 568A on one side, and on the other we'll require 568B. So I'll copy this from here and put it here. This is 568B. If you pay attention, when we connect cables like this, the first cable gets connected to the third cable or the third pin of the other side. As you can see, white green is on one side at the pin number one, but on the other end, it is at pin number three. Similarly, the second one goes and connects to the pin number six. Third connects to the pin number one, and sixth connects to the pin number two, which is your crossover cabling standard. That's what we have learned for crossover cables when we did the discussion. One connects to the pin number 3, 2 connects to the pin number 6, 3 connects to the 1, and 6 connects to the 2. Similarly, you can see here 1 connects to the pin number 3, second connects to the pin number 6, fifth to the third to the first, and sixth to the second. This is how the crossover and the straight through cables can be identified. Any questions or doubts? Okay, a very good news for anyone who is very confused right now that how I can recall all these color codes, or how can I make sure that a cable is straight through or a crossover cable. No need to worry. You just need to remember the color codes. Definitely, you need to memorize this color codes for crimping the cables into RJ45 appropriately. But it doesn't matter even if you use the wrong cable type between the devices. What does that mean? Between two same category devices, we have learned we will require crossover cable, correct? And between two different category devices, we'll require a straight through cable. But what if I connect a crossover cable between two same category devices? That's going to work fine. But what if, let's say, if I have a switch on one side and a switch on the other? So what type of cable should I use between these two devices? They are from same category. Should I go for straight through or for crossover? Crossover, right? But even if I add a straight through cable between these devices, then also it's going to work fine because of a technology called Auto MDIX. Auto MDIX stands for Automatic Medium Dependent Interface, where Even when a crossover cable was required between the switches, still if I add a straight through cable, still it's going to work fine. Why? Because auto MDIX changes the roles of these pins logically to make it work as per the cable which is used. So what will happen when I will deploy, let's say, a straight through cable between two same category devices? The working of the pins will be changed. The transmitting will become the receiving one and vice versa to make the connectivity work. So even if you use a wrong cable type, if the devices are enabled with auto MDIX, then also it's going to work fine. Make sense? We have a question. What is the use of color code? Color code is used for identifying what type of cable it is, whether it's a straight through cable or a crossover cable. No, it's going to be normal. Nowadays, whatever network devices are manufactured, the NIC, network interface card of those devices are enabled with auto MDIX, which can let you use any standard of cable between them. Any other questions before we move ahead? Okay. Finally, there is the fiber optic cables. Let's quickly talk about that as well. Fiber optic cables contains a glass fiber which is used for transmitting data from one side to the other with the help of light. It uses that particular glass fiber to transmit light from one side to the other, and that light signals will help us receive or transmit data between two devices. Okay. Fiber optic cables are of two types, a single mode or multi-mode. If I talk about single mode, it looks something like this. There will be outer jacket for the protection of the glass fiber. I'll put a image from Google as well. But yeah, this is how it looks like. There's going to be a very thin glass fiber inside my jacket, and inside that glass fiber, the single ray of light will be transmitted. Okay. It uses lasers and is used with a single strand of glass fiber, sending a single data signal. Whereas when we speak about multi-mode, it's going to be something like this, where multiple signals, or we can say multiple light signals, are transmitted, which will travel between my device. So one signal can be going like this, the other can be going like this. This type of cable is called multi-mode. The difference between them is that single mode is something that can be used uh, this can be spanned over a very large distance, and whereas when we talk about multi-mode, it can cover only uh, it can cover a lesser distance as compared to the single mode fiber optic cables. So it this one covers large distance, this one covers lesser distance. And then I can say this uses a single signal. This uses multiple signals to transmit data. Let me show you image of fiber optic cables as well. You can see this is how it looks like. There are multiple layers of protections. There is outer jacket, there is cladding for protecting the thin core, the glass fiber, which basically is going to use for transmitting the light from one end to the other. And then finally, the last medium of communication or transmitting data is wireless, which uses radio frequencies for transmitting data from one device to the other. These are the different types of medium or the types of uh, connections that we can establish between the devices. I'll just quickly check the group to check out if there are some questions. Okay, I see it has already answered. What about color codes of these cables? Console port cables are not supposed to have any color codes. These are single uh, type of cable which you can use for connecting to the console port of the device so that you can access it. Like I said, later on when we will be looking at some labs, I'll give you some idea of how the console port is utilized and can be connected with a PC to take the access of the router's CLI or the switch CLI and configure protocols on it. So all of that is something we are going to discuss. Don't worry about it. How to remember color codes? You have to learn them. There is no trick to that. You have to memorize them. Or otherwise, like you are always available with internet. Anytime you are working with some cables, you can do a quick Google and find out what are the color codes. What other questions do we have, guys? Let me know. How to distinguish between these cables? Lalit, you have to do, like I said, the color codes are something that you have to check. If the first end and the second end, both the ends have the same color scheme, that's your straight through cable. If they have different color schemes, you have to check the colors of the first pin, second pin, third pin. If you find them different, that's a crossover cable. Rollover cables, console cables, Harikrishnan, like I have said, I'll be speaking about them later on. As of now, just understand it is used for managing the router or the network devices. All right, I think then we all are good with the concepts that we have discussed today. Uh, that was the first session, and I'm hoping that you all must have enjoyed and got to learn something new out of it. Thank you so much for being attentive and with being interactive during this communication and the session. We'll be continuing tomorrow at the same time. We'll be exploring more details on the network concepts and we'll be gradually learning together to understand what is networking all about. There is no attendance link, like I have said earlier. Microsoft Teams automatically generates the attendance. You just need to be attentive. You just need to be active on all the sessions and you will be marked present. And we have another question. What is the example of anycast communication? Let's say you have multiple servers connected to you. All of them servers are used for the same service. So you can implement the same IP on the three servers. You have added three servers for making sure that there is redundancy. So if there are three servers, I can put the same IP on them. This works just with IPv6 for clarification. So you can put the same IP and whatever would be the nearest device or the nearest server, I'll be able to get my requirement fulfilled by that particular server. Sure thing, guys. See you at the same time tomorrow on the same link. Thank you so much. Bye bye. Take care. Have a nice day ahead.